Um, so in this video, we'll be going over the different types of collisions: elastic, inelastic, perfectly inelastic. Then we'll also talk about external forces, springs specifically, and then change in momentum, that formula. So we'll start out just talking about collisions. So in an elastic collision, here I draw a little diagram like this. If two particles are gonna hit each other, then after their forces, they're both moving away from each other, and the kinetic energy remains the same. That's something important. And in a perfect elastic collision, there's no net conversion, so there's no heat or sound that the energy is converted to. Now, for inelastic collisions, kinetic energy is lost, and in perfect inelastic collisions, objects, here I'll draw a little diagram right here. Say here's one particle, here's a second particle, this one's going to hit this one while this one's at rest. In a perfect inelastic collision, both particles will be moving together at a new speed or at a new velocity, and kinetic energy is lost. So yeah, those are some types of collisions. And now I'll just give the formula for the change in momentum. So that is going to be change in momentum equals the integral of force dt, integral of f dt. So that'll be useful. That's definitely an equation that you should know and write down and memorize. And then the last thing in the mini lecture is going to be just talking about springs. So springs have potential energy. Having potential energy, they have the potential to add kinetic energy. So let's just say there's a spring right here and a ball moving towards it. Of course, that's kinetic energy right now. There's potential energy in the spring, so once the ball hits the spring and goes back the other way, the spring compresses and then the ball goes back the other way. The potential energy will be used, and the kinetic energy of the ball will actually increase because of the spring and the potential energy that the spring has. So now we're going to move to the example. It's example problem 7. Here, I'll read it. Two carts of equal masses are on a horizontal surface with negligible friction. Cart A is approaching cart B, which is at rest. As shown in figure 1 above, attached to cart B is a spring that is initially compressed at the moment cart A collides with cart B. The spring is released and pushes cart A, as shown in figure 2 above. Which of the following correctly states what happens to the kinetic energy and the momentum of the two-cart system as a result of the collision compared to those quantities before the collision? Okay, so you get a little quick look at the problem and the potential answers. So, of course, in a normal without a spring, what would likely happen, or what could happen, would be that there would be a perfectly inelastic collision where cart B is at rest and cart A hits it, and then they move together at a speed, and kinetic energy is lost. But we have to remember the spring aspect of this problem. So, the spring, like I explained down here, the spring, once cart A hits the spring attached to cart B, that the potential energy that the spring has, that's gonna mean that there's actually gonna be more kinetic energy after the spring is compressed in the two carts because of the energy that the spring adds. So we already know that kinetic energy is going to increase and magnitude of momentum is going to increase as well. The kinetic energy is going to increase. Now for magnitude of momentum, this kinetic energy increase that's caused by the spring. So the spring is also going to increase the magnitude of momentum because the extra energy added translates to increased velocity of the two carts. As before, both one cart was moving and cart B was not moving. But now both cart A and cart B are moving in opposite directions, which the spring caused. So now that both are moving, the magnitude of momentum of both carts, of the combined two cart system, is increasing.